What if the night sky you see above you isn't just vast, it's endless? What if every star, every galaxy, every flicker of light is only the tiniest fraction of a reality that stretches on forever? And what if, somewhere far beyond the edge of what we can see, there's more? More stars, more space, more universes, maybe even another version of you lying in bed, asking the same impossible question: does space ever stop? It's a question so simple a child could ask it, yet so deep that science itself stumbles to answer. Because the truth is, when we talk about edges, we're really talking about ourselves. We want walls, boundaries, endings. But the universe may not believe in such things. Tonight, let's step gently into that question, slowly, curiously, wondering not just what lies beyond the stars, but what it means for us to even ask. Is space infinite, finite, folded, bubbling, or is it something stranger still, beyond anything we can imagine? We may not find a final answer, but in the asking, we discover something better: wonder. The kind of wonder that makes your heart race and your mind drift all at once. So settle in, let go of the day, and let's take a slow, starlit journey into one of the greatest mysteries of all. Does space end? Imagine you're floating upward, past the clouds, past the stratosphere, into the ink-black calm of space. The Earth shrinks below you, blue, white, alive, while the stars ahead spread out like glitter scattered on velvet. You drift past the moon, wave at Mars on your way by, and glide further still, until the solar system itself feels like a tiny island in an endless ocean. You keep going, never stopping, never turning back, and eventually a question sneaks into your thoughts, as soft as the background hum of space itself. Where does this end? Does the universe have an edge, a door, a curtain you can pull back to reveal whatever lies behind it? Or does it go on forever, stretching endlessly into directions your mind can barely grasp? It's the kind of question that feels both playful and profound, like asking whether time has a finish line, or whether numbers really keep climbing forever. And though it may sound like a simple bedtime thought, it's one that has kept astronomers, philosophers, and dreamers awake for centuries. So tonight, let's linger with this thought. Let's not rush to answers. Instead, let's float with it gently, like a feather caught in a breeze. Because in asking, does space end, we open a door not just to the cosmos, but to our own imagination. On Earth, almost everything has an edge. Rooms have walls, roads have curbs, even oceans, as vast as they feel when you stand on a beach, have shores. We are creatures raised on boundaries, raised to expect a stop sign somewhere up ahead. So when we look at the sky, our minds naturally want to impose the same rule. There must be a border, a finish line, a cosmic fence where everything ends. Maybe a giant wall of stars, maybe a black barrier, maybe even some kind of shimmering door, like in a science fiction film, waiting to be opened into the next level of existence. It sounds silly, childlike even, but only. Because we can't help ourselves. We are edge-seeking beings. Without edges, we feel lost. Before we can wonder where space ends, we need to pause and ask, what is it that we're talking about? What is space? For most of us, it's nothing. A big empty canvas where stars float and galaxies twirl. A void, a silence. But here's the twist. Space is not truly empty. The vacuum between galaxies hums with energy fields. Invisible particles flicker in and out of existence like shy fireflies. Light itself, the very thing we use to measure distance, ripples endlessly across it. Space, in a way, is more like a stage than a void, an invisible platform on which the cosmic play unfolds. So if the stage has no walls, where does it end? And if it does have walls, well, what lies beyond them? A second stage or no stage at all? Astronomers often talk about the observable universe. That's the part we can see, the region of space where light has had enough time to travel and reach us since the Big Bang. Think of it as a bubble, about 46 billion light years in radius. Everything inside that bubble is visible to us, at least in theory. Everything beyond it, still out there, but hidden by the slow speed of light and the young age of the cosmos. So in a sense, we do live inside an edge, but it's not an edge of space, it's an edge of vision. Like standing in the middle of a foggy field, you can only see so far, but the field doesn't necessarily stop where your eyes blur out. This is where the mystery deepens. Just because we can't see beyond the horizon doesn't mean nothing's there. It just means the light hasn't arrived yet. Here's the tricky part. Our brains don't really know how to imagine infinity. Try it. Picture a line that never ends. Your mind will stretch it out, but sooner or later you'll imagine a stop. Or you'll loop it into a circle, so it at least feels complete. Infinity doesn't sit comfortably with us. And yet, if space has no edge, infinity is what we're left with. An ocean with no shore, a road with no finish. It's both awe-inspiring and unsettling. To make it gentler, scientists sometimes compare it to the surface of the Earth. If you keep walking in one direction on Earth, you'll never find an edge. You'll just loop back around. Maybe the universe works like that, but in more than 3 dimensions. An endless loop without an edge, but not truly infinite either. But let's return to that funny thought. What if there really were a door at the end of space? A giant wall, standing silently in the blackness. You float closer and closer until, thunk, you bump into it. What then? Does it open like a wardrobe into Narnia? Or does it stand solid, unyielding, telling you this is as far as you go? If so, what's on the other side? Another space, another nothing, or something so far beyond our imagination that we don't even have words for it? This is where physics meets philosophy. Because the very idea of outside only makes sense if there is a bigger space to hold it. If the universe really does have an edge, then there has to be an outside. But how can there be an outside to everything? It's a puzzle that tickles the brain and refuses to let go. Now, don't worry if your head feels like it's spinning. That's normal. Thinking about infinity is like trying to hold a cloud in your hand. It just keeps slipping through your fingers. So take a breath, settle in. Let yourself imagine small things like socks. Yes, socks. You know how they mysteriously vanish from the laundry, as if slipping into some hidden dimension. Maybe, just maybe, the edge of space is where all those socks go. Scientists can't prove otherwise. Not yet. Sometimes, the best way to relax into a huge question is with a silly image. It reminds us that science isn't always about answers. It's about wonder. Here's what we do know. Space is expanding. Galaxies are moving away from us in every direction like raisins rising in bread dough. The further away they are, the faster they drift. Which means the universe isn't static. It's in motion, growing larger every second. But this creates a new riddle. If space is expanding, what is it expanding into? Is there some bigger room beyond it, waiting to be filled? Or is space creating itself as it stretches, no container required? The second idea is the one science leans toward. Space doesn't need an outside. It makes its own rules. Like a magician pulling scarves from a hat, it creates more room as it goes. That's hard to picture, but strangely calming. Space doesn't run out. It doesn't need a border. It just keeps being. So does space end? The honest answer is, we don't know. Maybe it stretches on forever. Maybe it loops back on itself. Maybe it hides an edge that we can never, ever reach. And that's the beauty of it, because sometimes the best questions are the ones that stay questions. They remind us that we are small, curious creatures in a vast, mysterious world. They remind us that not everything has to be solved before bedtime. So let the thought drift. Imagine doors or circles or oceans without shores. Imagine endless stars twinkling on into forever. And let that mystery cradle you gently like a lullaby from the cosmos. Because whether space ends or not, the wonder of it never does. Imagine taking a slow, steady breath. Inhale deeply, the chest rises, the air expands, and with it the world feels just a little bit larger for a moment. Now, imagine that same gentle breath on a cosmic scale, not inside your lungs, but inside the universe itself. That's what space has been doing, quietly, continuously for billions of years. Expanding, growing, stretching outward in every direction like a living thing, inhaling without ever exhaling. It's a strange thought. After all, when you look up at the night sky, the stars seem fixed, eternal. The constellations your ancestors painted onto the heavens thousands of years ago still look much the same today. Orion's belt hasn't drifted apart. The Big Dipper hasn't lost its handle. To our eyes, the universe looks still, unchanging. But in truth, it's anything but still. Behind the calm, behind the twinkling lights, there's a quiet motion, a secret stretching that never stops. Tonight, let's float into that motion. Let's gently unfold the mystery of how the universe itself is breathing and ask the question that follows naturally. If everything is expanding, what is it expanding into? The most famous way to picture the expanding universe is with a balloon. Not the kind you blow up quickly for a birthday party, no squeaking rubber here, but a calm, slow inflation. Imagine you take a blank balloon, scatter dots all over its surface, and begin to fill it with air. The dots are galaxies. As the balloon grows, every dot moves away from every other dot. None of the dots are traveling across the surface on their own. The surface itself is stretching. That's what our universe is doing. The galaxies aren't rushing through space like cars on a highway. Space itself is carrying them, stretching them apart like raisins baked into rising bread dough. From every vantage point, the story looks the same. Stand on one raisin, and every other raisin seems to drift away as the dough swells. It's a simple, beautiful picture. But like all analogies, it's only a shadow of the real thing, because while a balloon expands into the air of your living room, the universe isn't expanding into anything at all. Space isn't stretching into some bigger container. It's simply creating more space as it grows. And that's where the riddle begins. How do we even know this is happening? For centuries, humans assumed the universe was static, eternal, unchanging. Even Einstein thought so. In fact, when his equations of relativity suggested an expanding cosmos, he tweaked them to force a steady state, calling it his biggest blunder. Then, in the 1920s, a man named Edwin Hubble pointed a telescope at the night sky and noticed something astonishing. The galaxies weren't sitting still. They were red-shifted, stretched like the sound of a siren, fading as it passes you by. The farther away a galaxy was, the faster it seemed to be receding. The conclusion was unavoidable. Space itself was expanding, carrying galaxies with it. Suddenly, the universe wasn't a quiet stage set for eternity. It was alive with motion. It was breathing. Now, I know this all sounds pretty grand and serious, but let's bring it down to earth for a moment, because cosmic expansion has a funny side too. Have you ever wondered where your missing socks go? You put two in the dryer and only one comes back. People joke they've slipped into another dimension, but maybe they've just been red-shifted away, stretched so far by the expanding universe that they're now floating somewhere past Andromeda. Of course, that's not how it works. Your laundry is safe from cosmic inflation, but it's nice to imagine. The point is, expansion is everywhere, woven into the very fabric of reality, even if we don't feel it in our daily lives. Your living room isn't growing larger between sips of tea. Your coffee cup isn't drifting apart on the table. Gravity, atoms and molecules hold small things together. Expansion only matters on the grandest scales. Galaxy to galaxy, cluster to cluster. The big things are what stretch, while the little things hold tight. So the balloon grows, the galaxies drift. But here's the question that makes your thoughts wobble just a little. What's outside the balloon? When we blow up an actual balloon, it expands into the space of your room. But if the universe is the balloon, what surrounds it? The answer is both simple and mind-bending. There is no outside. The universe isn't expanding into anything. Instead, it's more like a painting being stretched on a canvas that makes itself as it goes. Space doesn't need an outside because it is the container, the stage, the everything. The outside is a concept that may not even apply. It feels unsatisfying, doesn't it? We want an outside. We want to picture the universe floating in a giant void like a marble in a box. But physics whispers the box doesn't exist. The marble doesn't need it. And so we're left with a mystery that tickles the imagination. If the balloon is all there is, then where do we stand when we ask the question? Perhaps we're dots on the balloon's surface, forever moving apart, unable to step outside, because outside is not a place that exists. Here's another surprise. Not only is the universe expanding, but it's expanding faster than we expected. In the late 1990s, two teams of astronomers studying distant supernovae made a startling discovery. Instead of slowing down, the expansion of the universe was accelerating. Something unseen, something we now call dark energy, was pushing galaxies apart like an invisible breath, speeding up the inflation of the balloon. Dark energy makes up about 70% of the universe, yet we have no idea what it actually is. It's like a cosmic puppeteer, pulling strings we can't see. Some say it's a property of space itself. Others suggest it's something more exotic, tied to fields we haven't discovered. All we know is that it's there, urging the universe to expand faster and faster, like a balloon that refuses to stop swelling. Now, before this starts to feel too heavy, let's take a gentle side road. Imagine the galaxies as party guests on that balloon. At first, everyone is clustered together, chatting politely. Then the music changes, and slowly, gently, they drift apart. Not because anyone's leaving the party, but because the dance floor itself is growing bigger. It's a cosmic waltz, but with no central stage, no spotlight. Everyone is moving away from everyone else, yet everyone feels like they're at the center, and in a way they are. From any galaxy, the universe looks like it's expanding around them, which means from where you sit tonight, wrapped in blankets or lying on your couch, you are at the very center of your observable universe, and so is everyone else. A cozy thought, isn't it? Where does this cosmic breath lead? Some scientists wonder if the universe will keep expanding forever, growing colder, emptier, lonelier, a fate called the heat death. In that distant future, stars would burn out, galaxies would drift apart until even their light couldn't cross the growing gaps, and the universe would fade into a quiet darkness. Others suggest the expansion might one day reverse, collapsing everything back into a big crunch. Or perhaps there will be cycles, expansion, collapse, expansion again, like the universe itself is inhaling and exhaling across eternity. The truth is, we don't know, and maybe that's exactly what makes it worth wondering about. So space isn't sitting still, it's breathing, expanding, carrying galaxies further and further apart, as if the universe itself is a balloon slowly filling with invisible air. But unlike a balloon in your living room, there is no outside. The growth is self-made, self-sustaining, a trick of nature we don't yet fully understand. And as you let this thought drift in your mind, remember, you don't need to solve it tonight. You don't need to picture infinity or define dark energy before sleep. Just let the idea float around you like starlight. Space is expanding, yes, but so is your imagination. So settle in, rest easy. Because whether the universe is infinite or not, whether it expands forever or folds back in on itself, one truth remains. In this moment, you are part of it, a small dot on the cosmic balloon, carried gently outward on the breath of the universe itself. And that perhaps is enough. Imagine standing on a quiet beach at night. The waves roll in, steady and calm, and the stars shimmer above you. Out on the dark ocean, you can only see as far as your eyes allow, just a strip of silver where the moonlight touches the water. Beyond that, blackness. You know the ocean keeps going, but your vision stops. Now lift that same feeling into the universe. Our eyes, whether they are human eyes peeking through a telescope or the eyes of vast space observatories floating above Earth, work in much the same way. They can only see so far. Beyond that, not because the stars aren't there, but because light itself hasn't had enough time to reach us. That invisible edge where vision ends and mystery begins has a name. Astronomers call it the cosmic horizon. It is the farthest wall our sight can touch, not because space stops, but because the light from beyond simply hasn't arrived yet. Beyond it, we don't know, darkness, silence, or perhaps everything. To make it gentler, let's imagine you are standing in a field on a misty morning. Fog curls around you, soft and silver. You can see a circle of trees maybe a few meters away, but then the mist thickens and swallows everything else. You know the world continues beyond that wall of haze, but from where you stand, it may as well be nothing. That's what the cosmic horizon is like. A fog, not of water droplets, but of time itself. Our universe is 13.8 billion years old. Light, the fastest traveler we know, has been rushing toward us since the very beginning. But because the universe is so young, there hasn't been enough time for light from farther away to arrive. It's like waiting for a letter that was mailed yesterday from the other side of the world. You simply can't have it yet. The result of this limitation is that each of us, each galaxy, each star system, sits inside a kind of bubble, the observable universe, a sphere centered on you, about 46 billion light years in radius. From the outside, it would look like a glowing snow globe filled with galaxies and stars. But that globe isn't the whole universe, it's just the part visible from your seat. And here's the strange part. If someone in a distant galaxy looked from their seat, they would see their own bubble too, just as large but slightly different. Their snow globe would overlap with ours in some places, but in others, it would reveal regions of the cosmos we can't yet see. In this way, the universe is like a patchwork quilt of perspectives, each one unique, none of them complete. Think of light as a patient, tireless messenger. It sets out from a galaxy billions of years ago, traveling faithfully across the emptiness. It crosses cosmic deserts, drifts past dark matter and dust, threads its way through clusters of stars, and finally reaches our telescopes. When we look at that light, we are looking into the past. We're not seeing the galaxy as it is today, we're seeing it as it was billions of years ago, when the light first began its journey. That's the quiet magic of astronomy. Every star, every galaxy is a kind of time machine. The farther away we look, the deeper into history we travel. But even the most patient messenger can't outrun time. If a galaxy is simply too far, its light hasn't had enough time to arrive, and so it remains hidden just beyond our cosmic horizon. Now, before this drifts into something too heavy, let's soften it with something cozy. The cosmic horizon is like your laundry basket. You know there are socks in there, but only the top layer is visible. You can only reach so far before the rest remains hidden. It doesn't mean the other socks don't exist, they're just not available yet. And as we know, some socks may never appear again, no matter how hard you look. The universe is a little like that basket, full of treasures, some visible, some still buried. And while scientists may not be searching for socks, they are searching for the hidden galaxies just beyond the edge of sight. Here's where it gets even stranger. The horizon is not fixed. Because the universe is expanding, the curtain is always moving. Light from galaxies we can't yet see may eventually cross into visibility. But at the same time, galaxies we can see now may someday drift so far away that their light can no longer reach us. It's a bittersweet thought. The night sky you see tonight, full of glittering stars and galaxies, won't look the same forever. In billions of years, much of it will have slipped beyond the cosmic horizon, out of reach forever. The universe is both generous and shy, showing us pieces of itself while keeping others hidden behind a moving veil. The horizon is not only about distance, it's about time. When we look toward it, we are also looking toward the beginning. The faintest, farthest light we can detect is the cosmic microwave background, the afterglow of the Big Bang itself. It's like a photograph of the universe as a newborn, still hot, still glowing, just 380,000 years after its birth. That light fills the entire sky, a gentle, uniform glow in every direction. It is the edge of our vision, the baby picture of everything. Beyond it we cannot see, not yet. Perhaps not ever. Let's pause here for a soft side thought. Think of the cosmic horizon as the ultimate bedtime curtain. You draw it across the window, and beyond it, the world becomes mystery. You don't need to see what's outside to rest easy. The curtain is enough. In the same way, the cosmic horizon is a kind of comfort. It tells us, here is your view. Beyond this, let it go. Let the unknown be unknown for now. It's not absence, it's possibility. Of course, curiosity doesn't rest so easily. What could lie beyond the horizon? More galaxies, more stars, perhaps entire structures larger than anything we've yet imagined. Some scientists believe the universe may be infinite, stretching without end. Others suggest it may curve back on itself, like the surface of a sphere. Still others whisper of multiverses, where beyond our horizon lies not more of our universe, but entirely different ones, each with their own rules. We can't know for sure. And maybe that's the sweetest part, because every boundary invites us to dream about what's on the other side. So what is the horizon of sight? It is the farthest we can see, a soft edge drawn not by walls but by time. A circle of light, stretching 46 billion light years in every direction, wrapping us in a cosmic bubble. Beyond it lies darkness. Not necessarily empty, but hidden, waiting. And as you drift off tonight, remember this: the universe doesn't show us everything at once. It reveals itself slowly, like a story told page by page, chapter by chapter. The horizon isn't the end, it's just the pause, the place where the next chapter begins. So let the thought soothe you. Beyond our sight, there is mystery. Beyond the curtain, there may be everything. And here within your own bubble of stars, you are part of it all, a tiny spark glowing gently in the great dark sea. Imagine holding a snow globe in your hands. You turn it gently, watch the glitter swirl, and notice the smooth roundness of the glass. No corners, no edges, just a continuous curve. Now imagine the universe might be something like that, a shape without boundaries, a cosmos where you could travel in one direction forever and, strangely enough, end up right back where you started. It sounds like the kind of idea you'd whisper in the dark, a playful "what if" before falling asleep. But it's also one of the deepest questions science has ever asked. What is the shape of the universe? Is it flat? Is it curved? Is it infinite? Or does it fold back on itself? Tonight, let's drift into those shapes together, slowly and gently, like tracing your finger along the edge of a dream. Here on Earth, shapes are simple. A table is flat, a ball is round, a saddle curves downward and upward at once. Our everyday world is full of edges, angles and forms we can picture. So naturally, when we look up at the universe, we want to ask, does it have a shape too? And the answer, from the best science we have, is yes. The universe does have a shape, not in the sense of a solid object floating in a bigger space, but in the way its geometry works. Does space curve? Does it fold? Does it stretch flat like an infinite sheet of paper? The answers depend on gravity, on energy, on the mysterious push and pull of dark matter and dark energy. It's like asking not what the universe looks like, but how it behaves, whether it bends paths, whether it loops, whether it allows infinity. The simplest shape is flat. Imagine a sheet of paper stretching in every direction. Walk straight across it and you'll never reach an edge, never loop back. This is what scientists call a flat universe. And surprisingly, our measurements suggest this might be the case. Light traveling across a flat universe moves in strass. Lines. Triangles add up neatly to 180 degrees. The cosmic microwave background, the afterglow of the Big Bang, spreads in patterns that look very much like what we'd expect from a flat geometry. But don't let the word flat fool you. Flat doesn't mean boring. Flat means infinite. A universe without end, stretching beyond imagination, with galaxies repeating endlessly like stars on wallpaper that goes on forever. Now, imagine instead the surface of a ball. It curves back on itself. If you walk straight in one direction long enough, you'll eventually loop back to where you started. The Earth works this way. Sailors once thought the horizon was an edge, but in truth, it's a curve. If the universe is spherical, then it is finite, but unbounded. That means it has no edge, no wall, but it does eventually close in on itself. You could sail through galaxies forever, only to find yourself circling back to your own, like living inside a cosmic snow globe, round and endless, but contained. There's a third possibility, the saddle shape. Picture a horse's saddle, curving downward in one direction and upward in another. A universe shaped like this is infinite too, but in a different way. Paths curve away from each other, parallel lines drift apart, the cosmos opens wide, endlessly stretching like a fabric pulled taut at the edges. This saddle shape is harder to picture, harder to hold in your mind's eye, but it has its own strange beauty, a universe forever expanding, forever curving away, with no possibility of looping back. Now, before we drift too far into geometry, let's soften the thought. Imagine space as a bedspread. Flat, it's like a neatly made blanket, stretched corner to corner. Spherical, it's like a blanket tucked around a ball. Saddle-shaped, it's like a blanket sagging in the middle of a hammock. The universe might be any one of these, and as you tuck yours, elfin tonight, you might smile at the thought the blanket around your shoulders is a miniature echo of the blanket of space itself. Cozy, infinite, or curving, you're wrapped in geometry either way. So which is it? What shape does the universe really have? The truth is we don't know for certain, but measurements from satellites like WMAP and Planck, which mapped the cosmic microwave background, suggest the universe is very, very close to flat. So close, in fact, that if it curves at all, the radius is so large we may never detect it. Think of standing on Earth. To your eyes, the ground beneath you looks flat, but that's only because the Earth is so large compared to you. The curvature is there, it's just invisible on human scales. The same may be true of the universe. To us, it looks flat, but only because its true curvature is beyond our ability to measure. Here's where things get mind-bending. A flat universe can be infinite, but it can also be finite if it loops back on itself in just the right way. Picture a video game map, where walking off the right side of the screen makes you reappear on the left. The space feels infinite, but it's actually wrapped around in a clever trick. Could our universe be like that? Finite, but with no edges, no walls. It's possible. And it's strangely comforting. Because in such a universe, you could wander forever and never hit a barrier, never fall off an edge. You'd just keep looping like a cosmic traveler in a grand circuit. And then, of course, there are shapes we can't even imagine, spaces with more than 3 dimensions. Geometries that defy our intuition. Mathematicians can describe them, scribble their equations, but our minds, trained by tables and balls and saddles, struggle to see them. It's like trying to explain color to someone who has only ever lived in black and white. The universe may be shaped in ways we can't yet grasp, waiting for our imagination to catch up. Why does the shape matter? Because it tells us about destiny. A flat or saddle-shaped universe may expand forever, cooling, thinning, drifting into silence. A spherical universe may one day collapse, folding back into itself in a big crunch. The geometry writes the ending of the story. But as you lie here tonight, listening, let the question rest. The shape of the universe isn't something you need to solve before sleep. It's enough to know that you are inside it, wrapped in its curve, floating on its flatness, carried in its saddle bend. Whatever its shape, it holds you. So, is the universe flat, round, or curved? The truth is, we don't know for sure. It may be infinite like paper, finite like a snow globe, or strange beyond our imagining. But in every case, the shapes have no sharp edges, no walls, no ends, just smooth, flowing curves, wrapping us in a geometry without boundaries. And maybe that's the most comforting thought of all. Because whether the cosmos is a sphere, a saddle, or a sheet, it holds us gently inside, without edges, without walls, like a blanket pulled across the night sky, covering us in the softest geometry of all, wonder. So close your eyes. Let the universe be round. Let it be flat. Let it be infinite. You don't have to decide. You only have to rest inside it, drifting, floating, safe in a shape without boundaries. Close your eyes for a moment and imagine a line, just a simple line, stretching out from you in both directions. Now picture yourself sliding along that line, forward, backward, again and again. How far can you go? Your mind tries to see the end, to picture some final stop, a wall, a boundary. But what if there is no wall? What if the line goes on forever? That's infinity. A word so simple it fits into a child's question, yet so vast it unsettles the greatest scientists. And when we ask whether space itself might be infinite, we're asking one of the deepest questions we can possibly ask. Is there an end to everything, or does it all stretch endlessly beyond what we can see? Tonight, let's drift slowly into this thought: infinity, friend or illusion? We humans like limits. They comfort us. A book has a last page. A song has a final note. Even a long road eventually reaches a turn. We measure, we count, we box things neatly. An edge is like a sigh of relief. It says, here, this is all there is. Infinity is the opposite. It refuses to be boxed. It says, no matter how far you go, there's still more. And that makes our minds itch. We want to picture it, but we can't. So, when we ask if the universe is infinite, we're poking at something we aren't really built to grasp. Like trying to hold water in your hands. It always slips away no matter how hard you try. Maybe the easiest way to begin is with numbers. 1, 2, 3. You can keep counting forever. There is no biggest number. Add one more and you've gone further. Infinity in math is simple, even playful. But space is different. Is the universe really like the number line, endless, stretching forever in every direction? Or is it more like a circle, looping back on itself, finite but without a sharp end? This is where the science gets tricky and where our imagination has to take over. Let's imagine just for a moment that space truly is infinite, no edges, no boundaries, galaxies upon galaxies stretching forever. In such a universe, every possibility exists somewhere. A star exactly like our sun, a planet exactly like Earth, and somewhere unimaginably far away, another version of you, brushing your teeth, sipping tea, maybe even lying in bed, listening to these same words. It sounds like science fiction, but mathematically, infinity almost demands it. In an endless roll of cosmic dice, every pattern eventually repeats. Infinity is not just big, it's everything, everywhere, all the time. Comforting, creepy, maybe both. But here's the counter thought. What if infinity is just an illusion? Maybe the universe only looks endless but actually curves back on itself like the surface of a sphere. You can keep walking forever, but eventually you'll circle back to where you began. In such a universe, forever is just a loop in disguise. Even mathematicians argue about infinity. Is it a real thing or just an idea? Some philosophers say infinity doesn't exist in nature, it's just a symbol, a placeholder for bigger than we can count. Others believe it's woven into reality itself. The universe, quiet as it is, hasn't told us which answer is right. Now let's soften all this cosmic math with something closer to home. Think about your sock drawer. You open it and it feels infinite, socks upon socks, none of them matching. But really, it's just finite chaos. The illusion of infinity hiding in cotton. The universe might be like that drawer, messy, overflowing, looking endless, but actually countable, if only we had the patience and the right pair of eyes. And maybe, just maybe, the missing socks are off, proving infinity for us, one drier cycle at a time. If the universe is infinite, then strange consequences follow. For one, there would be no center. Every point would be just as important as any other. Stand anywhere in infinity and you're in the middle. That means you, lying in bed, are the center of your infinite universe. And so is the person in a galaxy 10 billion light years away, a cozy paradox where everyone gets to feel special. Infinity also means no edge, no cosmic wall where the stars stop. You could sail in any direction forever without ever finding the end. Just endless galaxies, endless stars, endless space. But infinity also raises troubling questions. If everything repeats, if all possibilities exist somewhere, what does that mean for uniqueness? For meaning? If there are infinite versions of you, what makes this one matter? It's a thought that can be dizzying, but also strangely comforting, because see, even in infinity, this version of you, the one hearing these words, is the only one who exists here, now. So what does science say? Observations of the cosmic microwave background, the faint afterglow of the Big Bang, suggest the universe is very close to flat. And a flat universe could mean infinity, but flat could also mean finite, if space loops back in clever ways we haven't discovered yet. For now, the evidence leans toward infinity, but with a margin of mystery. The universe may be bigger than our instruments will ever allow us to measure. Our cosmic horizon, that bubble of sight, may be only the tiniest fraction of the whole. Infinity isn't just a scientific puzzle, it's a philosophical one. To some, the idea of infinity is terrifying. To others, it's liberating. If the universe is endless, then endings are illusions. Death, decay, even time itself may feel smaller, less final, in the face of something that never stops. But perhaps the truth is gentler. Infinity doesn't have to be solved, it doesn't have to be proven. It can be held instead as wonder, a reminder that not everything is meant to be wrapped neatly with a bow. Some things are simply too vast to fit in a box, too big to tuck under your pillow. So, is infinity a friend or an illusion? The honest answer is we don't know. The universe may stretch endlessly, rolling on without edges, or it may be finite, looping back in shapes we can't quite picture. But maybe the real gift of infinity is not the answer, it's the question. To wonder about forever is to stretch your mind beyond its usual walls, to practice awe, to remember how small we are and how vast the cosmos is. Tonight, as you rest, let infinity be a friend. Not something to fear, not something to solve, just something to wonder at. A horizon with no end, a lullaby that goes on, soft and endless as the stars themselves. Because whether infinity is real or not, the feeling it leaves us with is real enough, and sometimes that feeling is all we need. Imagine blowing soap bubbles on a quiet afternoon. The air shimmers with fragile spheres, each one glistening in the sunlight. Some are small, some large. They drift, bump, and sometimes merge. Each bubble holds its own little world of swirling colour. Now let your imagination drift upward. What if our universe is just one bubble among countless others? A cosmic foam of universes, each sealed within its own shimmering skin, floating in some vast invisible sea. This is the idea of the multiverse, and tonight we'll drift into it slowly, gently, like bubbles carried on a breeze. Our universe feels vast beyond measure, billions of galaxies, each filled with billions of stars, endless space stretching farther than our eyes can see. It seems impossible that anything could lie beyond. But some scientists whisper that maybe, just maybe, this vast universe is only one bubble in a greater froth of existence. We live inside one cosmic sphere, and beyond its delicate wall, other universes float, untouchable, invisible, but real. It's a humbling thought. You're not just a person in a galaxy, you're a person in a universe that might be one among trillions. This isn't just daydreaming. The bubble universe idea bubbles up, pun intended, from serious physics. When scientists studied the Big Bang, they realized the universe didn't just bang and settle, it inflated. Like a balloon, it swelled faster than light for a tiny fraction of a second. Inflation theory explains why the universe looks so smooth, why galaxies formed the way they did. But here's the twist. Some versions of inflation don't stop after one universe forms. They keep going, spawning bubble after bubble after bubble. Each bubble becomes its own universe with its own rules, its own physics. In one, gravity might be stronger. In another, stars might never form. In another, life might bloom in ways we can't imagine. And here we are, in ours, lucky enough to have galaxies, stars, planets, and socks that keep disappearing in the dryer. Before we float too far into cosmic inflation, let's pause with something simple. Think of blowing bubbles as a child, or maybe with your child or your niece, or just for the joy of it. How each bubble feels like its own little universe drifting in sunlight. For a moment, you forget the others and watch just one, glowing, spinning, carrying a tiny rainbow. That's our universe, our bubble. It's enough to fill a lifetime with wonder, even if there are countless others beyond reach. If other universes exist, why don't we see them? The answer is simple. Each bubble is sealed. The wall of our universe is expanding space itself, stretching faster than light. Nothing from the next bubble over can leak in. It's like being inside a snow globe. You see the glitter, the tiny trees, the frozen world, but no matter how hard you look, you can't see into the next globe on the shelf. Each one is complete unto itself. This means the multiverse, if it exists, is forever hidden from us. At least hidden in the usual sense. We can't peek outside, can't sail across, can't blow a hole in the bubble wall. We can only infer, only imagine. Still, the idea teases us. What might those other universes be like? Some may be short-lived, bubbles that popped almost as soon as they formed. Others might be sterile, universes without stars, without chemistry, without life. And some might be lush, filled with worlds stranger and more beautiful than anything we can dream. And in an infinite froth of bubbles, there may be universes eerily similar to ours. Universes where Earth exists, where history plays out almost the same, except one detail shifts. Maybe dinosaurs never went extinct. Maybe Rome never fell. Maybe there's another version of you lying in bed right now listening to this very story, except your pillow is blue instead of white. It sounds like science fiction, but it flows naturally from infinity. Given enough bubbles, every possibility finds a home. And then there's another twist. Some physicists argue that every time a choice is made, every time a coin flips, every time you decide coffee or tea, the universe splits. One bubble becomes two, each containing a version of events. This is the many worlds interpretation of quantum physics. It means the multiverse isn't just out there in distant bubbles. It's branching constantly around you with every breath. Somewhere, another you pick tea instead of coffee. Somewhere else you chose to stay in instead of going out. It's a dizzying thought, but also oddly comforting. Every path exists. Every version of you is out there, living its own quiet story in its own shimmering bubble. Now, before this begins to whirl too fast, let's pause. You don't need to solve the multiverse tonight. You don't need to picture infinity or track infinite versions of yourself. Just let the thought drift like a soap bubble, glowing and fragile. Maybe it's real, maybe it's not. Maybe the bubble bursts, maybe it doesn't. For now, you're here, in this bubble, in this universe, and that's more than enough. The multiverse remains a hypothesis. Some physicists love it, others roll their eyes. It's hard to test, because by definition, other universes lie beyond our horizon. But hints appear in the math. Inflation, quantum mechanics, string theory, they all leave cracks where multiple universes could fit. We may never know for sure. But then again, science has always thrived on questions just out of reach. Does the multiverse change anything for you and me? Perhaps not in daily life. Tomorrow, you'll still wake up, brush your teeth, and maybe lose another sock. But it changes how we see ourselves. Instead of being the center of the one universe, we become part of something larger, a froth of possibilities, a single bubble in an endless sea. It's humbling but also beautiful, because even if there are infinite bubbles, none of them are this one. None of them hold this version of you in this moment, listening to this story. That makes your bubble precious, no matter how many others exist. So, are we one bubble or many? Is our universe unique or part of an infinite foam? The answer may forever float just beyond reach, but perhaps that's the point. Because sometimes the most soothing thoughts are not answers, but questions. To wonder about bubbles beyond bubbles is to let your imagination drift like a child blowing soap bubbles in the sun, fragile, fleeting, beautiful. Tonight, as you close your eyes, let the thought drift with you. You are inside a bubble universe, floating through darkness, carried gently by laws you didn't choose. Whether there are others or not, this bubble is yours, this life, this version, this moment It's the one that matters. And if, out there, countless other bubbles shimmer unseen, let that only add to the lullaby, because the more bubbles there are, the more wondrous it is that you are here in this one now. Imagine a goldfish in a bowl. It swims in circles, nibbling flakes, staring out through the glass at a world it can sense but never touch. To the fish, the bowl feels like the entire universe. The water is its air, the glass its horizon. Beyond that, nothing. Or at least, nothing it can ever reach. Now imagine us, humanity, Earth, even our grandest telescopes. In some ways we are goldfish too, peering outward from inside a cosmic bowl. The water is space itself. The glass is our observable horizon. Everything we know, everything we can ever study, exists inside this transparent prism. Scientists have a word for it: the observable universe, a vast sphere around us, 46 billion light years in radius, filled with galaxies and stars. Beyond it, maybe more galaxies, maybe infinity, or maybe nothing at all. But here, inside our little cosmic cage, we are left to wonder, what lies beyond the glass? Why can't we see past this cage? The answer, as always, is light. Light travels fast, faster than anything we know. But even light has limits. The universe is 13.8 billion years old, and that means light from farther away simply hasn't had time to reach us. Imagine mailing a letter by boat from the far side of the ocean. If the boat left yesterday, you won't get it today. You have to wait. In the same way, galaxies far beyond our horizon may exist, but their light is still sailing toward us, across a sea too vast to cross in a single lifetime, or even in the lifetime of the cosmos so far. That's why we live in a cage of light, not because the universe ends, but because vision does. Picture yourself standing in the middle of a glowing sphere. Everywhere you look, galaxies paint the sky. That's your cosmic bubble, but it's not unique. Every observer, whether on Earth or a star in Andromeda or a galaxy 10 billion light years away, sits at the center of their own bubble. It's alive. It'll like each goldfish having its own bowl, overlapping with others, each limited by the distance light has traveled toward them. From inside, it feels complete, total. But step back, and you'd see a patchwork of overlapping cages, none of them showing the whole. Here's the strange thing: our cosmic cage isn't fixed. It's expanding, just like space itself. Every day, light from farther galaxies arrives, pushing our horizon outward. We see more. The glass of the bowl stretches. But there's a catch. Because space is expanding faster and faster, some galaxies are actually slipping away, carried beyond reach. They cross the horizon and vanish from our view forever, like ships fading into fog. That means our cosmic cage is both growing and shrinking at once. New light drifts in, but old galaxies drift out. We are always in motion, but never free. Before this starts to feel too heavy, let's soften it with a cozy thought. Think of your living room window at night. You see the houses across the street lamp, maybe the faint outlines of trees. Beyond that, darkness. You know the city continues, but from your window, it might as well end at the corner. The universe is like that window. Our telescopes are panes of glass, showing us what's near, what's bright. Beyond the corner, mystery. And that's okay. The view we have is beautiful enough to hold us. Why do scientists care so much about this cage? Because it defines what we can know. Every equation, every observation, every theory we build rests on what fits inside our observable universe. Beyond it, we can only guess. It's humbling. All our maps of the cosmos, all our discoveries about galaxies and black holes and cosmic radiation, they are sketches of just one small part of the whole. The rest remains hidden, like the unturned pages of a book. Could we ever escape our cage? Sadly, no. The speed of light is the ultimate speed limit. Even with the fastest spaceship imaginable, we could never cross the horizon. The glass bowl isn't just hard, it's absolute. In a way, that makes our situation even more like the goldfish. No matter how much we swim, we can't leave the water. No matter how much we look, the glass won't break. And yet, what a cage it is. Hundreds of billions of galaxies, trillions of stars, more planets than grains of sand on all the beaches of Earth. Even if we never touch what's beyond, what's inside is enough to fill endless lifetimes with wonder. Think of a goldfish again. It doesn't need to know the whole house outside its bowl to live a good life. It swims, it explores, it finds joy in the pebbles and plants inside its tiny world. We too can marvel at the wonders inside our bubble without needing to break the glass. Still, the question lingers, what lies beyond? We can't see directly, but we can make guesses. Some patterns in the cosmic microwave background hint that our bubble may be just one patch of a much larger quilt. Some theories suggest infinite space, stretching without end. Others whisper of multiverses, where countless other bubbles float. We may never know for sure. But isn't that part of the charm? The cage leaves us with mystery, and mystery is fuel for imagination. So here we are, swimming in our little cosmic cage, bounded not by walls of glass, but by time, by light, by the limits of what can reach us. Beyond the horizon may be more galaxies, more wonders, more everything. Or maybe it ends, or maybe it folds into something stranger than we can picture. But tonight, none of that matters. What matters is that inside this cage, we have stars to gaze at, we have galaxies to map, we have mysteries enough to last forever. So let yourself rest in the thought, you are a goal. To fish, yes, but in the most magnificent bowl imaginable, a cosmic sphere filled with light holding you gently. Don't worry about the glass. Don't worry about what lies beyond. Just drift, float, and marvel at the water you're in. Because sometimes the cage is not a prison, it's a cradle. And in that cradle, you are safe. Imagine standing on a train platform at night. One by one, the trains pull away, their lights fading into the distance. First slowly, then faster, until all you see are faint sparks swallowed by the dark. Now lift that image to the scale of the universe. The galaxies are the trains, and space itself is the track. They are pulling away, not because they are moving through space, but because space itself is stretching beneath them. And here's the surprising twist. Not only are the galaxies receding, they are accelerating, speeding up as they go. The farther away they are, the faster they vanish from sight. This is the future of the cosmos, a universe where expansion never stops, a universe where distance itself grows and grows, carrying the stars away until their light can no longer reach us. Tonight, let's float into that future together. Slow, steady, unhurried. The story of how the universe keeps expanding and what it means for everything inside. For a long time, scientists assumed the universe's expansion would eventually slow down. After all, gravity pulls. With so many galaxies, so much matter, shouldn't the expansion eventually ease, maybe even reverse? But in the 1990s, astronomers studying distant exploding stars, supernovae, found something shocking. The light didn't match a slowing universe. It matched one that was speeding up. Instead of collapsing or coasting, the universe was accelerating. Something invisible, something mysterious, was pushing galaxies apart. They called it dark energy. A placeholder name, really, because we don't know what it is. But whatever it is, it dominates our cosmos, making up about 70% of everything. An invisible hand, stretching the fabric of space faster and faster. Think of it like this. Imagine jogging on a treadmill. At first, the speed is gentle, something you can keep up with, but then the belt starts moving faster. You try to run, but the pace quickens. Soon, no matter how fast your legs move, you can't keep up. The galaxies are like joggers, and space is the treadmill. Except here, the treadmill never slows down. It keeps speeding up forever. And unlike in the gym, there's no stop button. So what does this accelerating future look like? Let's drift forward in time. Billions of years from now, the galaxies nearest to us will still shine in the night sky. Our own local group, home to the Milky Way, Andromeda, and a few dozen smaller galaxies, will remain bound together by gravity. We'll still have stars to see, still have neighbors to keep us company. But beyond our group, the story changes. The galaxies farther away will slip over the cosmic horizon. Their light, stretched thinner and thinner, will never reach us again. The night sky will grow emptier, fewer stars, fewer galaxies, until, eventually, only our local cluster will remain. It will feel as though we are alone in the dark, not because the universe ended, but because it expanded too much for us to see it anymore. It sounds lonely, doesn't it? But maybe not. Think about a quiet evening at home. Outside, the city still hums, the world still spins, but you don't hear it. You hear only the ticking of your own clock, the warmth of your own lamp. It's enough. The future of the universe may be like that, less noisy, less crowded, but still enough. A cozy bubble of stars glowing gently, carrying life, carrying stories, carrying the small spark of awareness that wonders about it all. Scientists don't know exactly how this future expansion will end, if it ever does. Here are a few possibilities. Heat death. Expansion continues forever. Stars burn out, galaxies drift apart, and the universe grows cold and dark, a silent eternity stretching without end. Big Rip. If dark energy grows stronger over time, expansion might not just separate galaxies, it could tear apart stars, planets, even atoms themselves. A dramatic finale where everything unravels into nothing. Gentle fade, or perhaps expansion will slow dark energy easing, leaving a universe that coasts quietly, a soft sigh instead of a violent ending. We don't yet know which path is ours. The equations are written in a language we're still learning to read. Now, before this gets too dark, let's pause with something silly. Imagine socks again. Yes, socks seem to appear a lot in cosmic discussions, don't they? If the universe keeps expanding, maybe that's where the missing socks go, slipping over the cosmic horizon, lost forever in accelerated space. It's not laundry chaos, it's physics. At least, that's a comforting excuse next time you lose one. What does this cosmic expansion mean for us, really? On the scale of human lives, not much. Tomorrow, the sun will rise, the moon will set, the Milky Way will arch across the sky, as it always has. Expansion happens on scales so vast, so slow, that to us it feels like stillness. But in another sense, it means everything. It means we live in a universe that is dynamic, alive, restless, a universe not content to sit quietly, but one that grows, stretches, evolves. And knowing that, even if it doesn't touch our daily lives, adds a richness to the simple act of looking at the stars. So the future keeps expanding. Galaxies drift away, the horizon grows darker, the stars grow fewer. But here, in this moment, we are part of the expansion too. We are past, Engers on the treadmill, carried outward gently into the unknown. It may sound lonely, but it doesn't have to be. The universe will never stop breathing, and as long as it breathes, we are part of it. Every heartbeat, every dream, every quiet night sky, all of it woven into the expanding fabric. So settle in with that thought. Don't fear the darkness ahead. Instead, see it as a lullaby, a soft reminder that everything changes, everything drifts, everything expands, and yet, even as the future slips away, this present moment is infinite in its own way. Because the future may keep expanding forever, but for now, the universe is here, full of stars, full of wonder, full of you. Picture yourself walking through a forest at dusk. The path winds gently forward, but mist begins to rise, blurring the trees. You can see only a few steps ahead. The rest dissolves into mystery. You could keep walking, but every step brings new fog. No matter how hard you try, you cannot see the whole forest at once. That's what asking, does space end, feels like. Physics takes you part of the way, offering equations, models, observations. But then mist rises, and philosophy steps in. Some questions are not just scientific, they are also about meaning, perspective, and how our minds shape the questions themselves. Tonight, let's linger in that meeting place, where physics meets philosophy, and the universe becomes not just numbers and stars, but a mirror for how we think. Physics begins with measurements. We look at the cosmic microwave background, map galaxies, measure curvature. Science tells us the universe is expanding, that it may be flat or infinite or finite and curved. It gives us probabilities, margins of error, confidence levels. But then comes the edge. If space had an end, physics asks, what would that mean? An end implies an outside. But if the universe is everything, how can there be an outside? That's where physics falters, because the very language of edges may not apply to the universe at all. Philosophy reminds us that our words come from human experience. We know edges because we live in houses, walk on roads, look at oceans with shorelines. But the cosmos may not follow human metaphors. Asking where does it end might be like asking what's north of the North Pole. The question itself bends in on itself. Still, philosophy doesn't stop there. It wonders, why does infinity disturb us? Why do we crave boundaries? Why is forever so hard to sit with? These are not just cosmic puzzles, they are human ones. Think about your bookshelf. No matter how many books you own, you always seem to want one more. Knowledge, like the universe, feels endless. You can finish a page, a chapter, a whole novel, but you never really finish reading. There's always another story waiting. In that way, infinity is familiar. It's not frightening, it's just the way curiosity works. Always another page, always another horizon. If we tried to answer cosmic questions with physics alone, we'd have numbers but no meaning. Expansion rates, curvature values, dark energy equations. Precise, beautiful but empty of feeling, like staring at sheet music without ever hearing the song. And if we answered with philosophy alone, we'd have meaning without anchor, dreams, metaphors, poetry, but no way to test or confirm them, like listening to a song without knowing whether the notes are in tune. It's only when the two meet, physics with its facts, philosophy with its questions, that the picture feels whole. One of the most profound philosophical ideas is that the universe doesn't just exist out there, it also exists in here as part of our minds. When we ask if space ends, we're really asking about the limits of thought. Can the human brain, evolved for hunting, eating, surviving, truly grasp infinity? Or are we like fish wandering about the ocean, unable to see its entirety, but still swimming in it? In this way, the universe becomes a mirror. Our questions about it reveal more about us than about the stars. Some philosophers suggest that even asking, "Does space end?" is a kind of trick. To ask whether it ends assumes that it could, but maybe the universe isn't the kind of thing that ends or doesn't end. Maybe it simply is, in a way beyond our categories. It's like holding a seashell to your ear. You ask, is this the ocean or not the ocean? The answer is both and neither. The shell holds an echo, not the sea itself. Our questions may be echoes too, shaped by the shell of our minds. Now, let's soften the thought with something cozy. Imagine your favorite mug of tea or coffee. Warm, smooth, familiar. If you tried to measure it only with physics, you'd get volume, temperature, density. If you tried to measure it only with philosophy, you get metaphors, comfort, ritual, meaning. But the truth of the mug is both warm liquid and warm feeling. The universe is like that mug, facts and meaning, physics and philosophy, both sipping from the same mystery. When physics and philosophy meet, they give us a range of possibilities. Maybe the universe is infinite. Maybe it's finite but unbounded, looping back on itself. Maybe the very words finite and infinite don't apply. Each option stretches the mind in a different way. Each one reminds us that reality is larger than language, larger than thought. So when physics meets philosophy, what do we find? Not answers, but doorways. Not edges, but invitations. The universe doesn't give us a final chapter, it gives us a question mark. And maybe that's enough, to rest in the question, to let infinity be infinity, to let mystery be mystery, to know that our human craving for boundaries is part of the story, but not the whole story. Tonight, as you drift into sleep, let the thought cradle you. Physics explains how the stars burn. Philosophy asks why we feel awe when we look at them. Together, they remind us that the universe is not just something we study. It's something we live inside, something we feel, something we are. So close your eyes. Don't worry about edges. Don't worry about infinity. Let physics and philosophy whisper together like two voices in the same lullaby, and let that lullaby carry you gently into dreams. Imagine standing on a hillside at night. The air is cool, the grass is damp, and above you the stars spill across the sky in a silver river. You tilt your head back and wonder, how far does this go? Does the sky keep unfolding forever, or does it end somewhere at a wall we cannot see? You don't get an answer. The stars just shine, silent and distant, and maybe that's the point. The universe doesn't always explain itself. Sometimes it only invites us to wonder. That is where our journey ends, or perhaps where it begins, in the gentle unknown. All along we've asked, does space end? We've stretched balloons, traced horizons, pictured bubbles, and whispered about infinity. Science has given us glimpses, maps, probabilities, measurements. Philosophy has given us questions, edges, meaning, perspective. And yet, after all of it, the answer remains uncertain. Space may end, it may not, it may loop, it may stretch forever. It may be stranger than any of our metaphors. The mystery remains. But maybe that's not a failure, maybe that's the gift. The unknown is not a wall blocking us. It is an open field, waiting. We humans love conclusions. We like to close books, tie ribbons, finish puzzles. To us, an unanswered question feels like a loose thread. But the cosmos doesn't weave its stories for our neat endings. It lets threads dangle. It leaves doors open. And perhaps that's why it feels so unsettling, this idea of not knowing. But imagine if we did know. Imagine if scientists announced tomorrow, space ends right here, exactly like this. Wouldn't that be smaller somehow? Wouldn't that shrink the wonder, tame the mystery? Sometimes not knowing keeps the magic alive. Think about lullabies. You never expect them to answer questions. They don't explain the world. They simply soothe, hum, drift. The universe may be like that. Less a textbook, more a lullaby. Not telling us where the edges are, but singing softly, wonder, wonder, wonder. And if you've ever misplaced a sock or forgotten why you walked into a room, you already know the universe has a sense of humor about mystery. Some unknowns are cosmic, some are cotton. Either way, they remind us that we don't have to solve everything before bedtime. Remember the cosmic horizon, the bubble of what we can see? It feels like a cage, but it's also a comfort. We don't need to see it all at once. The night sky gives us enough. 1,000 stars are plenty. A single galaxy is plenty. Even the glow of our own moon is enough to remind us that we're part of something bigger. The unknown doesn't mean emptiness. It means possibility. Science will go on. Telescopes will grow sharper. Equations will grow stranger. We may glimpse deeper into space, probe farther into time, map corners of the cosmos we can't yet imagine. But even then, even with the sharpest tools, some mystery will remain. There will always be a horizon, always a question mark. And perhaps that's why curiosity never ends, because there's always a next page, always a new unknown, always a fresh edge to press against. So, does space end? The truest answer is we don't know, and maybe we never will, but that doesn't make the journey pointless, it makes it beautiful. Because the unknown is not emptiness, it is the place where imagination lives. Every time you look up at the night sky, you're staring not just at stars, but at mystery itself. You're looking at the question, you're looking at the unknown. So let this be our lullaby tonight, the gentle unknown, the sky without edges, the space that may end or may not. Don't try to solve it, don't try to box it, just let it drift around you, soft as starlight. Because in the end, the universe is not just something to be measured, it is something to be felt. A mystery we live inside, a cradle of stars, rocking us gently, asking nothing but wonder in return. So close your eyes, let the unknown be gentle, let it soothe you, not frighten you, because the question of whether space ends may never be answered, but the beauty of asking it, that will last forever.